All right, today we are finding the area, and I just want to quickly review. Area is when you have a shape. This is obviously just a square, and we're going to use this side and this side, and we are multiplying them together to find the space of the entire center, and that is what area is. So with that in mind, today we're working with shapes like this, and I really can't just find the area of this enormous weird shaped shape because it's not just 4 regular sides. It's got all these weird sides and they're all different measurements. So we kind of play a game to make it easy. So what we're going to do is I'm going to cut it right here. And now what I have is I have a rectangle there, a little one, and I have a big rectangle here. I have 2 different shapes, and I'm going to find the area of both shapes on their own, and then I just add them together. And that's really easy to do. But if I were to try to do all of this in one step, it just kind of wouldn't work. So the first one I'm going to tackle is just this little guy up top. And I have my 2 numbers. I have a 3 here and a 2 here. So I'm going to multiply those and get the area. So 3 times 2 equals 6. So I know the area of this rectangle is 6. Then I'm going to move on. And I just wrote the 6 in the middle to know that this part, the area is 6. Then I'm going to move on to this big shape. And I need to identify which numbers are the important ones, because I have a 2 here, but that's only for this one side. It's not the whole side that I've kind of created for the shape. So that one isn't going to help me. This 6 is this entire edge, and I used part of this edge for the other rectangle, so that one won't help me either. So now I've eliminated that 2 and that 6. Those both kind of got X'd out when I divided this shape up. So now the only numbers I'm left with for this blue shape on the bottom is this 4 and this 5, because I'm looking at this bottom and then this side. So those are my 2 numbers, or my 2, like my length and my height. So 5 times 4 I can multiply. That equals 20. That's a 2, I promise. And I can write 20 in the middle of this shape. Now I have the area of 2 shapes, but originally they were together. So now I'm just going to put them together in an addition problem. So the area of the first big one was 20. The area of the second one was 6. And all I do is add them together, which is going to be 26. And that is the area of the big shape altogether. So it was actually much easier if I just broke it down into 2 little areas that were easy to solve and then brought them back together at the end. So we're going to practice that one more time. I'm going to make this a little bit bigger, make it a little bit easier to see. So this one, I have a spot where I could break it up. If I break it up like there, that doesn't really help me because I still have this weird shape right here. So what I'm actually going to do is break it this way and create the rectangle that is right here in green. And then the other rectangle that is this big giant one in blue. Now I have my 2 shapes that make up that big one, and I'm going to find the area. So this time I'm going to start with this giant one. And I can see I have a 4 here, and that looks like a good measurement because it's not part of where I broke it. And then this 4 doesn't look useful because it's not going down this whole side. So that 4 isn't going to help me. And this 4 on the bottom is the exact same as this top. So it's fine. I could use it, but they're the same number. But the other number I need with this 4 is the 10 because it's the other length that's across the entire blue side. So 10 and 4 are my two measurements for this blue rectangle. So over here, 10 times 4 equals 40. And I know that my area here is 40. Moving on to the little green one, I've got, this is a 2 here, which is the bottom side. This 2 is just getting in the way. This 2 is the exact same. So just like I had a 4 here and a 4 here, I have a 2 here and a 2 here, but they're the same. So I could use kind of either one. And then I have a 4, which is the top to bottom edge. So that's what I need. So I need the 2 and I need the 4, and that's the height. And then this is the length. So 2 times 4 equals 8. And now I can add up the areas from the two rectangles. 40 plus 8 equals 48. And that's my area. And I'm done. Going on to the word problems, I have 3. And we'll start with this green one. Christian fenced a rectangular section of his yard for his llama. So I'm already going to draw this kind of rectangle, and then I'm just going to draw a smiley face for the llama. The total perimeter. So perimeter is the fence around the outside. It's not the middle. So area is the middle where we multiply 2 edges. Perimeter is adding the outside. So make sure you know the difference because we just jumped back to perimeter. The total perimeter of the fenced area, so P stands for perimeter, equals 22 feet. And that abbreviation is FT. The width, so that's the like the left side to the right side, or like the bottom, that's what width is 8. And the length is what we need to find out. So I'm looking for this side. So if this bottom edge is 8, this top edge is 8 because the lengths on the top and bottom are the same. So now I need to figure out what's left over on the sides. So I'm going to take the total and minus what I already know, which is the 8 on the bottom and the 8 on the top. So 22 minus 8 twice, and 8 twice is 16 because 8 times 2. Or I could just subtract 8 and then subtract 8 again. So I'm going to subtract 16 and save myself a step. So 2 minus 6 I can't do, so I'm going to regroup and borrow a 10. 12 minus 6 is 6, and then 1 minus 1 is 0. So I have 6 left over that I'm going to divide up between this side and this side. If I put 6 here and 6 here, the perimeter would be bigger than 22. So I have to split the 6 in half. And 6 divided by 2 using our multiplication facts or division facts is going to be 3. So I'm going to use a different color, but I'm going to have a 3 on this side and a 3 on this side. And then I could add them all up just like you do to solve perimeter and check to make sure I get to 22. So 8 plus 8 is 16. And then plus 3 and 3 more, or 6 more. And 3 plus 3 is 6, plus 6 more is 12, and 1 plus 1 is 2. And I got back to the 22, which means the perimeter is 22, and I got back to the beginning, and I'm good. Next one is a little harder, and it's also asking about area, not perimeter, so I have to go back and forth in my brain. Sheila is painting one wall of her bedroom. Her wall is rectangular, and the width is 10 feet, while the height, I lost my spot, is 8 feet. There is a door on that wall that is not getting painted. So this one's tricky, and that's why I brought it up. I'm going to show you. So we have a wall, and we have a door on that wall. So I need to find the area of how much is going to be painted, but the width of the wall let's see, 10 feet. And the height is 8 feet. I have to go back and find the information in my word problem. There is a door that will not get painted, and the measurements for the door are 7 by 4. What is the area that will get painted? The point is that I need to paint this much of the wall and not paint the door. So I'm going to solve the area for the entire wall, including the door. Then I'm going to take the door out of the area magically. And this is how we do it. First, I'm going to take the area of the wall, which the whole wall was 10 and 8. So 10 times 8 was 80. And that's the area for this entire wall. But I don't want to paint the door. So I'm going to solve the area for the door, which was 7 and 4. And 7 times 4 is 28. And I want to take it out, which is subtraction. So I'm going to do, I need more room. I'm going to do a little 80 minus 28. 0 minus 8 I can't do, so I'm going to need to regroup and borrow a 10. 10 minus 8 is 2, little 2. And then 7 minus 2 is 5. So the area that will get painted is 52 because I took out the area of the door that won't get painted. So that one is 2 steps, and you have to subtract instead of like adding 2 pieces together. So watch for that one. And the last one is very, very similar. Amy is helping her mom paint the wall in the living room. I'm going to draw the wall now so that I don't have to go back and find the information later. The wall is 10 feet by 14 feet. Got it? However, there is a window, drawing a window, and it measures 4 feet by 5 feet. 4 feet by 5 feet. Got it? What is the area that she will paint? You can't see the bottom of that typed out, but that's what it says. So same thing. We're going to paint a wall, but we can't paint over the window. So we're going to solve the area for the whole wall and then take out the area for the window since that doesn't get painted. So the first step, the wall, 10 times 14. 14, well, you can add the 0 on at the end, but you could also solve it with the standard algorithm. But 14 times 1 is 14, then add on the 0. So the area for the entire wall is 140. Then I'm going to take out the area for the window. So we have 4 and 5. And 4 times 5 equals 20. That's the area for the window, which is what I need to subtract from the total area of the wall. So 0 minus 0 is 0. 4 minus 2 is 2. And 1 minus nothing, you just bring it down, and I have a 1. So 120 is what will be left over to paint for the wall, but not paint the window. And we're done.